Hi guys, welcome to the channel. So today I'll be discussing about dynamic method dispatch or dynamic dispatch, or also known as multiple dispatch or double dispatch. So multiple dispatch uses the runtime types of the arguments to decide which method to call. So according to the definition, this multiple dispatch uses the runtime types of more than one argument to a method call to determine which method body to run. So according to the definition, this thing revolves around the inheritance, because inheritance and polymorphism. So in polymorphism, we have different methods with different arguments. So this deals with that only. So in let's say, yeah, but before that, PS give me modern languages like Java, PyTHN doesn't support this dynamic dispatch. Dynamic dispatch. So modern languages like Java and Python doesn't support dynamic dispatch. It only supports single dispatch. So according to this multiple dispatch means, let's say you have two arguments, and those two arguments will decide which method to call. The runtime types of those two arguments will decide which object to call. Let's say you have one method, this one, and this is another method, but the name of this method is same, but just the arguments are different. So the argument at the runtime, the type of the argument, like the instance of we use, right? That the type of the argument will decide which method to call. This one, or sorry, this one or this one. It will be decided at the runtime. And this is what dynamic dispatch tells us. So since Java and Python doesn't support dynamic dispatch, and let's see why. Like in practical, like how it doesn't support. So in single dispatch languages like Java and Python, the first argument will only take part in the method dispatch. So what does this mean? So let's say you have car C is equals to new car. And what you want to do? Car C dot drive, and you want to drive it at first gear. So this is your object. You create an object and you call this drive method on that object. So what in single dispatch language, what it says is like only the first argument. So here the first argument is the C. So this will only take part in the dynamic method lookup. So this C will take part in dynamic method LWP. Since this is also an argument, right? The C is also an argument to the method drive, right? So this C is also known as the receiver object. So this C is also called receiver object. So this receiver object will only take part in the dynamic method lookup, which is the first argument of the method. The second argument is this one. So this one will not take part in the dynamic method lookup. Only the C, which is the receiver, will take part in the dynamic method lookup. So inside this drive method, let's say I have this drive method here, drive, and it takes an argument arg. So if I print here this print, so what this will print here? This prints this C object, will print the whole C object. If I do this inside the drive method, if I print this, the keyword, it will print the whole C. It will print the whole C object. So the class of this C. So what is C? The runtime type of this C. So this C can be anything, right? This car can hold a sports car. This C can hold a sports car, any car, like dumping cars, etc. But that runtime object will define which drive method will be called. So this C only takes part in the dynamic method lookup, not the other argument, which is this one. So this C is only responsible for the dynamic method lookup. The class of this first argument decides which method to be executed. So this C decides which method should be executed. Let's say I have this car, okay, car C. So now if I do here, car C is equals to new sports car. Since sports car extends car, we can do this. We can store the child reference, we can store child object with parent reference. So now if I do C dot drive 1, So now the sports car drive method will be called. This is known as the runtime type of this. So what is the runtime type of this car now? This now has changed to sports car. So the class of the class of the first argument here, first argument is C, as we have discussed, like this is the receiver. So the class of this first argument, like the runtime type of this first argument, will decide which drive method will be called. And this is the first dispatch. But this argument will not take part in the dispatch method. Only the one. The C will take part in the dynamic method dispatch. So let's see with an example. Let's say I have dynamic. I guess this one. Test. These are the classes. Let me delete these ones. Yeah, so I have this test method, and this is test class. I have this test class, and I have one printer which has two methods, print and print. This is the overloaded method. This contains object O and this string. And I have an ink printer which extends printer and which is overridden these two methods. So these are two overloaded methods in ink printer. So now if I keep a string inside the object, I can do this because object is the parent class of all classes in Java. So now if I print this line system.out.println o.getClass.getName, this will give me string. Now I am creating a ink printer object, but I am using the parent reference to store the child object. Now if I do p.print and I am sending this o, which I created string. So ink printer. So let's first discuss. Which method will be called. This one, this printer class print, or this ink printer print. So as we have discussed, in Java, the first argument, which is this p, which is also known as the receiver, will take part in the dynamic method lookup. And the class of this p determines which print method will be called. This I have told you. The class of this p, the class or runtime of p will decide which method will be called. So what is runtime of p now? Ink printer. So ink printer print will be called. Now it comes like O. O is object of type string, but it is kept in object reference. So now which method will be called? Which method will be called? This printing string using ink printer or printing object with ink printer? Let's see. Let's save it. Java C test. Java test. So this is this print coming from here, get name, and this print O is printing object using printer. So printing object using ink printer. So you can see I have passed string, but it is not running this method, but this one. This is what single dispatch says. Single dispatch is done. Why? Because you can see we have two arguments going to this print. One is p, which is the receiver argument, and this is o. So we have discussed in single dispatch, only this p receiver object will take part in the dynamic method dispatch. So p, the class or the runtime of p is what? Ink printer. So ink printer print method will be called, but the second dispatch, which is this object o, is going string, but it is printing object. So this resolution is not getting done because of Java only supports single dispatch. Let's say it's Java supported for discussion's sake. So let's say Java supported this dynamic dispatch. So what would have been we have got what the output we would have got in the in this console, we have got printing string using printer. So only one argument is taking part in the method dispatch. So this is Java is only so this is why we are telling Java supports single dispatch, and that dispatch or that method lookup is done based on the receiver argument, which is the first argument, and it is done the class or the runtime of this p decides which method will be called. Since this ink printer, we straight away got to the ink printer. This is done using runtime. So we straight away got in this ink printer and we have ran this print. And since it doesn't support double dispatch, it is running what we have passed. Depends on the reference of the parent, on the reference we are using. Object reference we are using. So object, it will go to the object. So this is why Java is called a single dispatch. I have another example which I will also discuss, which is the dynamic, this one. So let's say I have a vehicle class, which is abstract, which I have drive and collide, and I have class car, which extends vehicle, which has overridden the drive method, overridden the collide method, and I have overloaded two this method is overloaded using bike and truck, and I have one truck class which extends vehicle, and I have bike class which extends vehicle. So now if I create a class in the main method, which if I do vehicle car new car, so what I'm doing, I'm using parent reference to keep the child object. So now if I do car.drive, which will run, so we know that with parent reference we can only call parent methods, but if the parent method is overridden by the child class, we can also call those overridden methods, right? What I said is like if we have a parent with parent reference, we can only call with parent reference containing child object, we can only call the parent methods. So if I have a parent reference is vehicle car, so we can only call vehicle related methods here, not car. But we can also call car methods only if those methods have been overridden by this the car class. So if I do car.drive, we will get generic car start sound. So let's run it and see what we'll get. You see generic start sound, car start sound. So we got generic car start sound. So why did we get it? Same method, the single dispatch. What we told you, like the runtime of this car, runtime object. What is the runtime object of car? It is car. Sorry, runtime object of this C is maybe this the reference variable is of type vehicle, but the runtime is of car. So the runtime or the class will decide the if I am getting right, like the class or the runtime object of this reference variable will decide which drive method to call. So car.drive, we have car. So the runtime of this car is the receiver object. So receiver will decide. Receiver will take part in the dynamic method lookup and will decide which drive method to call. So the class or the runtime type of this car reference variable will decide which drive will to call. So the runtime is of car, so the car method will be called. Car drive method will be called. Let's say the car didn't override this drive method, then the parent method will be called. Parent drive method will be called. So let's say if I remove this drive from here, now let's do one thing. You can see generic vehicle start sound. So with car, you can, so I have removed the drive method from this vehicle, so it is going to this generic vehicle start sound. Generic vehicle start sound. So let's keep this method here. Yeah. So now I have created a new object of type bike, which also extends this vehicle class. But I've kept it in the parent. So parent reference is storing the child object. So now if I do car.collide and I pass this bike, what will be which method will be called? So this should be called, right? So let's check. But it is getting generic collision. This is because Java supports single dispatch, the same thing. The first dispatch is done by this car, with the runtime of this car is new car object. Maybe the reference is of type vehicle, but the runtime is car. So it is going to this car class. And it is running the collide method. But here it is not dynamically looking up to the runtime object. If it would have looked up to the runtime, this method would have run. But here it is going to this vehicle C and is printing generic collision. And this is why we say the Java supports single dispatch. The runtime of this doesn't even take part in the method resolution. The runtime of this bike is what bike. So this is not taking part in the dynamic method resolution. And this is compile time. So at the compile time, it takes the reference type. It takes the reference type and it calls this vehicle. So this way we say like Java supports single dispatch, not dynamic dispatch. So if you want to like make Java do another thing, like if Java supported this dynamic dispatch, this bike car collided with bike would have been called. So since Java supports single dispatch, we will to implement multiple dispatch. We have various design patterns like the visitor design pattern, which mimics double dispatch and which helps us to perform double dispatch in Java. So thanks for watching the video. So thanks for watching the video, and I will be covering the visitor design pattern in my next video. Thanks for watching the video, and please like it if you like the video.